All right. Hello, everybody. As I told you before the break, you may not remember, I said I wouldn't be here today. My daughter's having a procedure done. I would like you all to still be able to do this lesson, and I'm going to make these notes pretty quick. You can pause as you need if you feel like I'm going too fast. And I also might figure out a way for the sub to put this on the big screen. And if you all need to pause as a class, you can do the same as well. Okay, so today's lesson is going to be an intro to logarithmic functions, and we are also going to compare them to exponential functions because it's the one function that you can't understand unless you relate it to another function. Like quadratics, they can stand alone. Cubics, they can stand alone. But to understand a logarithm function, you have to connect it back to an exponential function. So I think that's what makes them tricky. Here's the rule. As follows. An exponential function has a base that's a number, and the x is the variable. So examples of exponential functions are y equals 2 to the x power, y equals 3 to the x power. So as long as the base is our number and our exponent is our variable, that makes it an exponential function. Now, a logarithm function is basically the inverse of an exponential function, and we'll get more into inverse functions as we move forward. I would normally talk about that a little more in this lesson, but I'm trying to save time since you all are having to watch this video. So either way, the base of an exponential function is actually the base of a logarithm function. It just serves a different role. It's written in subscript instead of being written as the physical base with an exponent. So whatever number you see written here, if you convert it to a logarithm, you would see that same number written here. Also, whatever number you see as the exponent of an exponential problem, you would then see that it is the answer to a logarithm problem. And then finally, the answer to an exponential problem over here is actually the number that's written right here in a logarithm function. It makes a lot more sense as I progress through these notes, so hang with me. Okay, so if I were to complete this table, substituting these numbers in for x right here, we can start over here. 2 to the 0 power would be 1. 2 to the first power would be 2. 2 to the second power would be 4. 2 to the third power would be 8. And 2 to the fourth power would be 16. We would say this is growing exponentially because it's an exponential function, but you can see that when things grow exponentially, they grow fast. We use that in our everyday language, like, oh, it's growing exponentially. And we're just saying that it starts slow and then it shoots off really fast. Now, on the other side, things are going to flatten out. If I do 2 to the negative 1, we can send that negative exponent downstairs, and it's actually just 1 over 2 to the 1, or 2 to the first power, and that's 1/2. If I do 2 to the negative 2, negative exponent goes downstairs. That ends up 1 over 2 squared, which is 1 over 4. We can see here that our answers are becoming what I just wrote on this other side, but with a 1 over it. And that previous answer, when I say that previous answer, the answer from over here, it is now over here, but in the denominator. And then finally, without showing you any math for this last one, this would be 1 over 16. Our answers are getting smaller and smaller and smaller when we go back this way, but they never will go to 0. It'll just be 1 over another big number, 1 over another number, 1 over another. I'll never get negative. So an exponential function is unique in that the outputs are never negative. Unless there's a shift, and we'll get into that when we start graphing. If we shift the whole graph down, that's a whole other thing. But right here, this parent graph, 2 to the x power, will never go negative, and it will also never go to 0. It's just impossible. It'll get really close, but it'll never touch it. Again, we'll get into all that when we get into our graphing in the next lesson. So I don't want to get ahead of myself. All right, now let's look at the table for logarithms. Logarithms are the answers to exponential problems, okay? The answers to exponential problems. So I'm going to start way down here. If I do log base 2 of 4, okay, so right now in green, I'm circling that x. That's where I'm substituting my numbers. I'm substituting in a 4. The answer is the exponent. The answer is the exponent from an exponential problem. So basically 2 to what power would give you 4? 2 to what power would give you 4? So you almost have to think backwards. I've got my base 2. I've raised it to an exponent to get 4. What exponent was that? And of course, that is the second power. Okay. Next, let's do 8. 2 to what power would give you 8? 2 to what power would give you 8? Well, 2 to the third power would give me 8. So my answer here is 3. Our answers are exponents. Your answers to logarithm problems are exponents. So next, that's a 16, sorry. 2 to what power would give me 16? 2 to what power would give me 16? Well, 2 times 2 times 2 times 2 is 16, so 2 to the fourth power would give me 16. So my answer is 4. Now, I hope you see the pattern that's going here, and I hope you're looking back up at the previous table and going, my answers are just flipped. Well, yeah, they are. I told you at the beginning that these two are inverses of each other. So inverse means I can switch x and y and get the inverse of the other function. So as I switch my x and y, the inverse of 2 to the x is log base 2. Let's do a couple more. I know we see the pattern at this point, but I just want to make a point. 2 to what power would give me 2? 2 to what power would give me 2? 1. Log base 2 of 1. 2 to what power would give me 1? 2 to what power would give me 1? Well, anything to the 0 power gives me 1. Is that matching up with our table above? Absolutely it is. I'm pretty sure we can guess that this one's -1, this one's -2, and so on. I just want to show it to you. Log base 2 and put a 1/2 here. 2 to what power would give me 1/2? 2 to what power would give me 1/2? Well, 2 to the -1 power will give me 1/2 because I just did it a minute ago. And so I'm going to go ahead and bring these other numbers down and show you that these two tables are exactly like each other but flipped. All right. Now I'm going to get into the little arrow rule. You've seen me doing this little arrow. I'm going to talk about it. And our goal today is just to go from exponential form to logarithm form and back and forth. So by the time we get to the bottom of these notes, you're going to go, this is pretty easy. It started off a little crazy, but it's pretty easy. So here's your rule. What you do is you always start at the base. So find your base. Then pass by your equal sign. So if my equal sign were on this side, I would go this way first. Okay, so go past your equal sign first, and the number that you pass by that's on the other side of your equal sign is your exponent. So basically, you're going to start with your base and go 2 to the third power, and then you're going to wrap around until you land on the other number, and the other number is your answer. So going this way would be 2 to the third power equals 8. And so it's 2 to the third power equals 8. 2 pass by your equal sign, that's your exponent, and the other number that you land on is the answer. So 2 to the third power equals 8. And when you write down these answers, they got to make sense. So if you wrap in the wrong direction or move in the wrong direction, you're going to be left with something like, I don't know, 8 to the second. Let's think of a good one. Hang on. Well, let's just do this. If you went in the wrong direction and you did like 8 to the third equals 2, you're going to look at that and go, no, it's not. So like when you land on your answer, you should be your exponential answer. That's the easy one to tell. The logarithm's not easy to tell. But when you land on your exponential answers, you should be able to look at it and go, yeah, that's correct. Okay. If you go in the wrong order, you will not have a correct answer. Okay. So here we go. 3, pass by your equal sign. The number that you pass by is your exponent, and whatever you land on is the answer. So this is 3 to the fourth equals x. And if needed, you could solve for x. I'm not going to do that in this video, but if you needed, you could put 3 to the fourth power in your calculator. Okay. All right, next. 8 to the x power. 8 to the x power equals 64. And I could do that mental math. I know my x equals 2. Again, you don't always have to solve for x, but if you were asked to, I can see that my x equals 2. Next, start at your base. My base this time is x to the third power equals, what do you land on? 125. And I could do some mental math there or put this in my calculator. I know the cube root, if I took the cube root of both sides of 125 is 5. So my answer there would be x is 5 if I had to solve for x. All right, last one. 2 to the -4 equals x. 2 to the -4 equals x. And if I wanted to find that answer, I send that negative number downstairs, put a 1 over it. I know it's the denominator. I just say downstairs to be silly. And it looks like my final answer there would be 1 over 16. On your homework, though, this is all you're trying to do. You're just trying to, everything I have boxed in, that's what you're trying to do. You're trying to just put it in exponential form. You're not actually trying to solve for x. That's just a little extra that we have on the notes. So everything I have boxed in there in blue is your goal of this lesson, to be able to convert. All right, now we have to convert the other way. Okay, we have to go from exponential form back to logarithm form. So here's how I do it. I don't have a fun wraparound trick. What I do is I just go ahead and write down log, and I identify the base. My base is x, so I make it a base. Okay, then the exponent is always on the other side of the equal sign. So I put the 3 over there, and the only thing left is 216. Then when I'm done, I do a quick wraparound and make sure it checks. X to the third equals 216. Yep, that's what it says. So I'm good. Next, write down log. Identify the base. Base is 8. Make 8 in that little subscript. Then the exponent goes on the other side of the equal sign. Leave a little space. And then the only thing left is my 1 over 64. If you want to put parentheses around it, as you start to have fractions and different things, if you want to put those grouping symbols to let you know that it is a log of 1 over 64, you can. It's not necessarily necessary. That was redundant. Okay, next, log. What is my base? My base is x. What is it what is the exponent? The exponent goes on the other side. The exponent is -3. And then fill in that missing blank that you left space with or for with a 1 over 27. All right. Last, you can put this in your calculator. Okay. You can go, and I think there's a number of different ways to do this. I can't remember. There's a fun little trick to getting it. Let's see. Okay, so you can type, I know the way that I usually do it, but there were 2 ways. If you go to math and you scroll down, so press the math button and scroll down, you will find log base. It'll say log base like this. Okay. You can also do alpha window. Some of you may prefer to do that because you don't really have to scroll if you do alpha, and then you press window. Window's up top. Okay, it's on the top of your calculator. And if you do alpha window, it is option number 5. Okay. If you do this, and I don't want to switch screens and it'll make your video longer, but if you do this, you can just type the numbers right in. So right now I've done this, and I'm going to put a 2 where the base is, and I'm going to put a 32, and it says my answer is 5. So the answer to log base 2 equals 32 is 5. Now, when you're done on your homework, you're going to have some of these problems. It seems pretty simple. You just get to put in your calculator. When you're done, so you'll have this, log base 2 of 32 equals 5. I also want you to add this, 2 to the 5th power equals 32. I want you to write down, and let me see, I feel like my camera's in the way. There you go, Scott, of my video. When you go to write that down, I want you to have both your answer. So I'm highlighting this for you. You want to have your answer, and then you want to have the exponential equation that it's equivalent to. So your Google form, you'll put a 5 in there, but on the paper I will collect, I need to see this part right here. So this part, you will turn it on paper. I wonder if I can move me around here. There we go. This part you're going to turn in on paper. This part is going to be on your paper and on your Google form. Okay. So here, if I do log base 3 of 1 over 27, this would equal a negative exponent. That's how we get these numbers in our denominator. And so this is going to be a -3 if I put it in my calculator, and that is because 3 to the -3 equals 1 over 27. So this is what you would write on your paper, and then this answer you would have there as well, but you'd also have it entered in your Google form. And the last one, 7. Once we put this in our calculator, to the 0 power, you will get 0. That's what your calculator will tell you, and that is because 7 to the 0 power is 1. 7 to the 0 power is 1. Okay. I hope that's okay. I've got a few rules for you. Okay. I got a few rules for you. Number 1, let me erase these real quickly. Okay. First rule, you can't take the log of 0. And that's because the answer for an exponent problem can't be 0, right? I told you that you'll never quite get to 0. So since the answer to an exponential problem can't be 0, you can't take the log of 0. If you try to take the log of 0, and if you can't remember this, just try it. It'll say error. And I want you all to note that that means it's undefined. There is no output. You also can't take the log of a negative number. Remember I said the answers will never go negative to that exponential problem, so you can't physically take the logarithm of a negative number. If you try, it will also say error. On your Google form, if this happens, type in the word undefined. I think with a capital U or a lowercase u, it'll be fine. But you cannot take the log of a negative number. All right, next. These are just fun rules. These you don't have to memorize, but it's just worth noting that if your base and this number here, let me find a good highlighter. If your base and this number match, the answer is always 1 because a number raised to the first power is itself. So if these two numbers match, your answer will always be 1. That's why I have two B's there. And if the answer to a logarithm problem is 0, you know this number had to be a 1 because anything to the 0 power is 1. Anything to the 0 power is 1. So when you get 0 as your answer, that's why, because there's a 1 in that spot. The last thing I want to mention, this is a big thing, so I hope you've stayed with me this long. If you don't see a base, okay, so if this is your problem, if you don't see a base, it's the weirdest one of all because we assume that if we don't see a number, it's a 1. In square root, we assume it's a 2. Logarithms, we assume it's a 10. The world operates in base 10. If you look at the metric system in other parts of the world, we operate in base 10, and logarithms work with base 10 if you don't specify. So if ever you don't see a base, you assume it is a 10, okay? All right, your job is to try the homework assignment and the exit slip. We'll see how things go, and I will see you all back again tomorrow. So let me hit stop on this video, and thank you all.